Welcome to the lecture series on the subject thermodynamics and heat transfer. So today we are going to discuss about the second chapter, which is steam generators and steam turbines. So as we know that in thermal power plant, these are the two main components, that is boilers and turbines. Since both these components are included in this second chapter, if we consider lengthwise, this topic will be very huge. So first we will be discussing about steam generators, and prior to that, first we will discuss about steam. So what is steam, how steam is formed, what are the different types of steam. We will be discussing this in today's lecture. So let's start with steam. Okay, so what is steam? Steam is nothing but it is the gaseous form of water which is invisible when it is pure and dry. So just here in the background you can see this is nothing but steam. It is used as a working substance in many applications. For example, we can consider steam engines or in boilers and turbines. So this steam is used basically in thermal power plants for generating electricity. Again, steam is utilized in sugar factories while manufacturing sugar. Again, in various industries such as food industry, textile industry, the steam has many applications. So now we will see what are the different types of heat, because before going to study how steam formation takes place, it is necessary to understand these two concepts, that is sensible heat and latent heat. So let's start with the sensible heat. So what is sensible heat? When an object is heated, its temperature will rise and heat is added to that object. So this increase in heat is called as sensible heat. Similarly, when heat is removed from an object, its temperature will fall or decrease, and the heat is removed from that object, which is called as sensible heat. So if the heat causes the change in temperature of an object, then it is called as sensible heat. In other words, we can also say that if we are able to measure the heat with the help of some instrument, then it is called as sensible heat. Like if we consider an example of a human body, so with the help of thermometer we can sense what is the temperature of the body. Or we can just consider another example. So let's just assume that we are having some water which is at normal temperature, and if we add some heat to that water, then we can observe with the help of instrument like thermometer that the temperature of the water will go on increasing as we are adding heat to that. So this change in temperature is nothing but sensible heat. And one more point important here is we have to note that is in case of sensible heat, I mean to say when we are adding some heat to an object, then if sensible heat is added to an object, then there will be no any change in phase of that object. Okay, on the other hand, if we talk about this latent heat, then the heat that does not affects the temperature of the substance, but there will be change in phase. Okay, so if we are adding some heat to the object and if it does not make any change in the temperature, but instead if there is change in phase of that object, then we call it as latent heat. So for example, here is given water will remain at 100 degrees Celsius when boiling, because when the water is at 100 degrees Celsius and if we are adding heat to it, then what actually happens, the phase change process starts. So we are going to discuss this in detail in the next slide, where we are going to study about how the steam formation takes place. So the heat added to keep the water boiling is called as latent heat. Heat that causes a change of state, or we can call it as phase with no change in temperature, is called as latent heat. So these are the two types of heat which we should understand. Now let's see how the steam formation takes place. So we will be discussing this point, that is formation or generation of steam at constant pressure. So the formation of steam we have to refer this diagram. So here you can observe that on the x-axis we are having heat supply, whereas on the y-axis we are having temperature. So we will be starting with one assumption how the steam formation takes place. So this graph is divided into several parts. So nomenclature is given to each and every line. So we will be discussing what actually these lines represent in this diagram. So we will be starting with point A, and first we will be talking about this line AB. So just first assumption, we should note that in the formation of steam, first we are considering 1 kg of ice which is at temperature minus 10 degrees Celsius, which is below the freezing point. We know that the freezing point of water is 0 degrees Celsius and the boiling temperature is 100 degrees Celsius. So we are considering 1 kg of ice which is at minus 10 degrees Celsius. So this is minus 10 degrees Celsius. We will be starting from this point. So we are heating this 1 kg ice which is at minus 10 degrees Celsius at constant pressure P. So as we go on adding heat to that ice, what will happen? The temperature of ice will start to increase. So we can just represent this in this manner. As we are adding heat to that ice, with the increase in heat there will be increase in temperature also. So the temperature will start increasing in the order minus initially it was minus 10. So as we go on adding heat, it will go minus 9 degree, minus 8, minus 7, minus 6. So in this pattern it will be go up till we reach at 0 degrees Celsius. So this point B represents we are having ice which is in solid state at 0 degrees Celsius. So since we are adding heat, it does not happen that immediately ice is converted into water. Okay, so as we go on adding heat, what will happen? There will be rise in temperature, that is from minus 10 degrees Celsius we will be reaching to 0 degrees Celsius, which is represented by point B. So you should note that at point B what we are having, we will be having 0 degrees Celsius ice. So this entire 1 kg of ice will be in solid state only at point B. So you should note that in previous slide what we have discussed, what is a sensible heat and latent heat. So here we are increasing, we are adding heat to the ice and there is no change in phase, but there is just the rise in temperature. So this type of heat which is added to the ice is called as sensible heat, since there is rise in temperature and no change in phase. Now it is interesting to know that if at point B, which is 100% ice at 0 degrees Celsius, if we further add heat to this ice, then there will be no any further rise in temperature, because whatever the heat we are adding, you can see in this graph, whatever the heat we are adding to this ice, what will happen? The phase change process will begin from this point. So as we go on adding heat, what will happen? Whatever the 1 kg ice we were having, it will start to convert into liquid form, that is phase change will take place. So if we just consider any point which is close to this point B, then at this point we will be having, say let's assume this point. So at this point what will happen? We will be having a larger quantity of solid ice and a few particles of liquid. So if this process will go on continue, that is the solid will be get converted into liquid as we are adding the heat, and the process will continue until we reach at point G. So at this particular point, that is G, we will be having 0 degrees Celsius, but it will be all liquid form. So the ice which was available at point B, on further addition of heat, what happens? The ice will be totally converted into liquid form until it reaches the point G. So in this region, if we consider this B to G line, this line represents that latent heat is added to the system, and we have already discussed that this is the heat which we cannot measure with the help of any instrument, since the temperature will remain constant whatever the heat is added, it is utilized for phase conversion. So this was about the second line, that is B to G. We'll see this in this slide. So it's by mistake, I think this is represented by G. Just consider here as point C. So whatever I have just discussed now, that was related with this line, that is B to G, or we can consider it as B to C. So see here it is given, on further addition of heat, that is at point B, if we further add heat, the ice will start melting and its temperature will remain constant at 0 degrees Celsius, and it absorbs the latent heat of fusion and converts completely into water at 0 degrees Celsius at this point. Now let's see what happens if we further add heat at point G or at point C. So the next region we are representing by this line, that is line C to D. Okay, so if we consider this line, if we add further heat at this point G, then we can again see that there will be a rise in temperature. So in this region we are having many practical applications, like for domestic purpose. You might have seen if you are keeping some water in a container and that container is placed on the LPG gas or burner. So that same process is represented here. So if you take the water at 0 degrees Celsius and if you start adding heat to that, then there will be no any change in phase, but instead whatever the heat you are adding into that, it will result in the rise in temperature of the water. So this process will continue, that is, as we go on adding the heat, the temperature of the water will start increasing until it reaches at this point D, where the temperature will be 100 degrees Celsius. So just mark that at point D we will be having 100% liquid only, but its temperature will be 100 degrees Celsius. So this was all about line C to D, which is called as sensible heating of water from 0 degrees Celsius to saturation. So here just note that whatever the heat is added, it is called as sensible heat, because on this line at any point we can measure what is the temperature of the water with the help of any instrument. So now let's move to the next line, that is line D to E. So this line is called as latent heat of vaporization of water. So here you can see that there will be no any change in temperature even if we are adding some heat to that system. So as I told that at point D we are having 100% liquid, which is at 100 degrees Celsius. So on further addition of heat, there will be no any rise in temperature, but instead whatever the heat is supplied to that water, it will be utilized for phase conversion. That is, the water will start converting into vapor or gases or steam. So this process will continue until we reach at point E. This point E represents 100% we will be having gaseous form, that is we will be having 100% steam at point E. Just note that the temperature at this point E will be 100 degrees Celsius only. So from D to E, whatever the heat is added, that is utilized for phase conversion. So that is represented by this alphabets, that is L plus V, which is nothing but liquid plus vapor. So if we consider any point near to this E point, then we will be having a large quantity of vapor or steam and a few particles of moisture or liquid. Now we will see the last region, which is represented by line E to F. So this is called as superheating of steam. Now once we are at a point E where 100% steam is available, if we go on adding further heat at this point E, then we can see the further change in the temperature. That is here again it will be sensible heat. So whatever the heat we are adding after this point E, it will result in the rise in temperature of that steam. So whatever the steam is available in this region, that is in E to F region, it is called as superheated steam. It means that in this part if we consider any point on this line that is in this region E to F, it represents that there is no any moisture content in this steam. So for this we will be again discussing what are the different types of steam in further slides. So this is how ice is converted into steam. So for this region we'll just go through these lines that if further heat is added, the temperature of dry saturated steam will start rising from its saturation temperature and it converts into superheated steam. So this superheated steam is actually utilized in many applications. Most of the time if we are using wet steam, then it can have several problems such as corrosion wherever we are utilizing this wet steam. Even if you consider thermal power plant or steam power plant, there also we are utilizing the superheated steam for running the turbines. So you should note that what is the use of this superheated steam. So this is all about how the formation of steam takes place. One more point, the heat absorbed is the sensible heat. As I told you here, there is one term which is called as degree of superheat. So we will be defining this term in next slide. Here we are having the temperature entropy diagram, which is nothing but T, we call it as TS diagram. So here we can see on y-axis we are having the temperature, on x-axis we are having entropy. So this graph, whatever we have seen in previous slides, that is formation of steam, we can represent those processes on this graph. So this graph consists of a bell-shaped curve which is divided into two parts. So we can consider this first part which starts from point A and ends at point E. So this line is called as saturated liquid line. If we consider further region from this point E till H, then this line is called as saturated vapor line. So what it actually means that if we consider any point on this entire line, that is from A to E, if we consider any point, then it represents that we are having 100% liquid at that particular point. On the other hand, if you consider any point on this line which is ranging from this E to H, then it indicates that if we consider any point on this line, then it indicates that we are having 100% vapor or dry steam at that particular point. If we consider the region below this bell-shaped curve, then it is called as wet region. So we have seen the latent heat which is added at several phases while studying the formation of steam. So if we consider any region below this bell-shaped curve, then it is called as a wet region. The point which differentiates both these lines, that is saturated liquid line and saturated vapor line, those are called that is called as critical point. So this critical point differentiates liquid line with the vapor line. If we consider this left region of this curve AE, then this region is called as subcooled region, and if we consider the region above this line E to H, then this region is called as superheated region. This dotted line is represented by alphabet X, which is nothing but dryness fraction, and the value of dryness fraction ranges from 0 to 1. So based on dryness fraction, we could understand that how much water percentage or how much moisture content is available in the given steam. So you can observe that here we are having 0.1. If we consider the value of X on this line, then it will be 0. So this 0.1 represents that we are having few moisture particles in this region. So as we move towards this, or if we consider this line, we can see here X is equal to 0.9, that is 90% moisture is if we consider this X equal to 0.9, or if we consider X on this line, which is nothing but saturated vapor line, then it represents that we are having 100% steam. Okay, so higher the value of X, then it will represent that the lesser will be the moisture content. So this was all about the TS diagram. So whatever we have discussed, all those is given. You can just go through these statements which are given. Whatever the diagram is there, it is discussed in this slide. Now let's see what are the different types of steam, or what are the various conditions of steam. So in previous slide we have discussed how the formation of steam takes place, right from ice of -10 degrees Celsius. We have converted it into superheated steam. So let's see now different types of steam. So first is dry saturated steam. So this is nothing but, if we consider any point on that saturated vapor line, then it represents, we can call that steam as dry saturated steam. So basically this steam does not contain any moisture, and hence it is called as dry saturated steam. It contains a sufficient amount of heat energy to maintain all the water in gaseous state. So if we remove even a small amount of heat from this steam, then it may contain moisture. So it is called as dry saturated steam. So saturation means we are just close to the moisture content. So if it will be depending on how much amount of heat you are maintaining in that water, or in that gas or steam. So on further, even if you add certain more amount of heat to it, then it will be going into superheated region. And if you remove some small amount of heat from this steam, then it will be going into the wet region. So now let's see what is the wet steam. So if the steam is containing any percentage of some liquid particles, or if the steam is having some amount of moisture content, then we call it as wet steam. Next is the superheated steam. So in the previous slide we have seen the region E to F, which represents this superheated steam. So once we have got the dry saturated steam, and if we still add further heat to it, that is, it will be the sensible heat. So due to this sensible heat, what will happen? The temperature of the steam will go on rising. So that is called as superheated steam. So if the temperature of the steam is greater than that of the boiling point corresponding to the pressure of the steam generation, then the steam is known as superheated steam. And the last term is the degree of superheat. So it is defined as the difference between superheated temperature of steam and its saturation temperature. So this is the mathematical formula how we are calculating the degree of superheat, that is the temperature of superheated steam minus the temperature of saturated steam. So if just for example, if we consider that the steam is superheated, we know the boiling point of boiling temperature of water at normal pressure, that is at atmospheric pressure, it is 100 degrees Celsius. So at 100 degrees Celsius we will be having 100% steam, which we can call it as saturated steam or dry saturated steam. So if we further add some heat into this dry saturated steam, and as a result of this heat addition, say the temperature of the steam is rises to 150 degrees Celsius. So that 150 degrees Celsius is nothing but our this T superheated, that is temperature of superheated steam, and the saturation temperature will be 100. So we will be calculating the degree of superheat as 150 minus 100, which will be nothing but 50 degree Celsius. So this 50 degree Celsius will be called as degree of superheat. So I hope that you have understood the different types of steam, that is dry saturated steam, wet steam, superheated steam, and the difference of superheated and dry saturated steam, which is termed as degree of superheat.